Hello, good afternoon. I'm Mehrdad Mahoutian, co-founder and CTO of Carbicrete. During my PhD program in McGill University, I developed a technology which is now used in Carbicrete. So Carbicrete is a McGill spin-off which develops cement-free concrete. So let's start with the cement problem. So after water, concrete is the second most used material in the world. In average, one person consumes 1 ton of concrete per year, which is huge. And traditionally, concrete is made of cement, aggregate, and water. And we know that cement production is a very dirty and energy-intensive process. Production of 1 ton of cement produces 1 ton of CO2 into atmosphere. So it is a very dirty material. So consider this amount of pollution. Cement production accounts for 5% of total CO2 emission into atmosphere. So just imagine one single material, cement, is responsible for 5% of total CO2 emission. What about steel slag? Steel slag is a byproduct of steelmaking factories. Every year, about 130 million tons of these materials is produced around the world. However, this byproduct material doesn't show any hydraulic properties or doesn't show any pozzolanic behavior. That's why its application in the construction industry is limited. In some cases, steel slag is used as aggregate in road, as base or basement actually. So the application for slag is limited. That's why most of the steel slag ends up into the landfill. So far, we understand what's the problem. The problem is with cement, with the CO2, and also with slag, which there is no application for it. So what's the solution? Carbicrete developed a technology to produce cement-free and concrete carbon-negative concrete. So in our technology, we do not use cement. Cement is replaced with steel slag, and we cure concrete with carbon dioxide instead of steam. The final product is stronger, more durable, and even cheaper compared to the traditional cement-based material. What we offer to the concrete producer, we offer them the process, the know-how, the material to produce high-quality and carbon-negative concrete. Over the past few years, it has been a huge pressure on the construction industry to reduce their carbon footprint, and we believe we can provide the feasible solution to produce carbon-negative materials. And we foresee a huge market opportunity for this technology. What's the reason? First is the material cost. We can make cheaper material, cheaper product compared to the traditional process. So the final cost of product is less than the traditional product. The second one is carbon tax. Recently, the government of Canada has imposed a new regulation called carbon tax, which forces the industries and factories to pay tax for their CO2 emission. That's why these industries, they are interested in adopting our technology in order to reducing their emission and also their tax. And also, the government of Canada has promised a large infrastructure spending, and it promised to improve the sustainability across Canada. So combination of these two factors altogether suggests a promising future for this technology. If I want to wrap up the benefits of this technology, as I mentioned before, this technology ends up to the cheaper product compared to the traditional product. Consider let's say one of these cinder blocks or masonry units, which is the focus of this presentation and this talk. So adopting our technology, we can avoid 3 kilograms of CO2 into atmosphere. So why this is 3 kilograms? Because every single cement-based product block consumes 2 kilograms of cement, which is equivalent of 2 kilograms of CO2. Since we eliminate use of cement, 2 kilograms is eliminated. And also in the process of making these blocks, we permanently capture CO2 by 1 kilogram. So in total, we can avoid emission of 3 kilograms of CO2 into atmosphere. The final product shows a better mechanical and durability properties compared to the conventional cement-based material. So in the next slide, I'm going to talk a bit about the properties. And that our technology provides a feasible way to permanently capture CO2. I mean, there are few carbon capture solutions which is available around the world. However, all of those are very expensive and almost they are not feasible to practice. This table shows some of the properties of our block and also cement-based block. So in conclusion, we can say that our block is stronger compared to the traditional block. So if I want to summarize what we do, we develop a technology to produce carbon negative and cement-free concrete. We do not use cement, we use byproduct of other industries, and also we use carbon dioxide to cure the concrete. So our products are stronger, durable, and also cheaper compared to the traditional cement-based block. And at this stage, we are looking for investor to build a pilot plan to show our technology and process to the customers. In the next few months, we are going to hear about the international X Prize competition, which is a $20 million competition. We are going to hear if who is going to be the winner of that competition. Thank you.